Dijkstra's algorithm, BFS, can already find shortest paths, but only when every edge counts the same. What if edges have different costs, different travel times, different distances, different prices? Then you need something smarter than BFS. You need Dijkstra's. Here's a weighted graph. Each edge has a number on it. Think of it as distance or driving time, or dollars. We want the cheapest total path from a starting node to every other node. You can't just count hops anymore. A path with more edges might actually be cheaper than a path with fewer, as long as each edge is small enough. So we need an algorithm that cares about the weights, not just the number of steps. Here's how Dijkstra works at a high level. Start at the source node, set its distance to 0 and every other node to infinity. We don't know a path yet. Now repeat this. Pick the unvisited node with the smallest current distance. For each of its neighbors, ask, is the path through me cheaper than the distance that node already has? If yes, update it. This update step is called relaxation. Mark the node as visited and repeat. To grab the smallest distance node efficiently each time, you use a priority queue. Let me trace it on a small graph. 4 nodes, A, B, C, D, edges. A to B costs 5. A to C costs 2. B to D costs 1. C to D costs 6. We want the shortest path from A to D. Start, A is 0, everything else is infinity. Visit A, relax its neighbors. B gets 5, C gets 2. Now pick the smallest unvisited, that's C at 2. Relax C's neighbors. D becomes 2 plus 6, which is 8. Next smallest is B at 5. Relax B's neighbors. D via B is 5 plus 1, 6. That's better than 8, so update D to 6. Visit D, we're done. Shortest A to D is 6, going A, B, D. Your turn. Can Dijkstra's algorithm handle negative edge weights? It's C. No. Negative edges break the greedy logic Dijkstra relies on, because a path you already finalized might still get shorter if a negative edge shows up later. For graphs with negative weights, use Bellman-Ford instead. Dijkstra is basically BFS with a priority queue. Greedy, elegant, and the right tool for shortest paths in weighted graphs. Just keep those edge weights non-negative and you're set.